Welcome back to my YouTube channel. Good afternoon. Again, this is your host, Santos Cabelan Jr. Wishing you always a good day. Guys, today what I'm going to do is to give you an idea or give you a hint if you are going to apply for a post as a BMS engineer, okay? Or something that is related to building management system. Let's say you can apply also for if you are a graduate of any technical course and you have experience with building automation, and if you want to level up, you want to become a BMS supervisor or foreman, then this tutorial is for you. First, if you want to be a BMS engineer, of course, I have a tutorial. This is how to become a BMS engineer part 79. This is BMS interview questions, okay? So you will be, if you will be watching this video tutorial, you will find the most relevant question that the company will ask you or the interviewee. Okay, I mean the interviewer. Okay, so you can watch this video tutorial and try to see what are the possible questions that you might encounter. Okay, now but anyway, today I'm going to do another video tutorial related to this BMS interview or BMS test that you might encounter if you are applying for the specific post as a BMS engineer or BMS technician or BMS foreman. Okay, now let me share my schematic here. Okay, guys, what I have here is a control schematic for a supply pan, or maybe we can say this one is supply pan pressurization pan or supply pressurization pan. Okay. Now, guys, actually, as I said, you can review my BMS interview questions. Then maybe they will give you a simple test. Maybe the guy who's going to give you the test will try to know if you are aware or if you have good understanding of control and monitoring points. Okay, so maybe he will give you a control schematics. Okay, now for example, this control schematics. Okay, now as you can see here, we have several control and monitoring points. Okay, now when I say control point, that is the usually are the start stop command or the control for opening a certain valve actuator or damper actuator, and you are controlling a variable frequency drive. So VFD speed control is a control point. Okay, anything that is related to start and stopping an equipment, that is a control point. Okay, now how about monitoring points? Monitoring points I like status, then temperature, or values of different sensors. Okay, now for this one I will just give you an idea. Okay, actually this is a control schematic in one of the BMS project. Okay, now this is for staircase pressurization fan. Okay, now what are the control and monitoring points? Actually, as you can see here, we have here our DDC. Now basically we have this type of points: analog input, analog output, digital input, and digital output. Okay, now, if you are applying, as I said, if you are applying for a BMS engineer or any work related to building management system, you might be asked, okay, maybe the guy who will test you will remove the where the point will go. Okay, then he will tell you, okay, complete this control and monitoring points where it should fall. Okay, so let's have an example like this one, smoke detector. So I have here a smoke detector field device. Okay, now as you can see here, the point falls into a digital input. Actually, this is not A1, this is I. Okay, so digital input, this smoke detector. So meaning, inside the smoke detector, there will be a smoke sensor probe. And if it will sense a smoke, there will be a normally open and normally closed contact, usually they will use the normally open contact. When it senses smoke, that contact will close. So that is a digital input, because we say digital input because there will be only two values, on and off. That's why it is digital input. Okay. So where that point should fall. So if you will trace the point, it should fall in the digital input. Okay. So if you will put it in an analog input, then maybe you will try to justify why did you assign it to analog input. What is the reason? Okay. Then maybe you can say because if your answer is correct, like say you will say because this smoke detector, it has a analog, maybe there is a control or a control output signal which is 0 to 10 volts corresponding to 0 to 100% smoke. Then maybe the guy who is testing you will say, okay, you're right. But basically smoke detector, they will just be using a volt free contact. Okay. A status which is on or off. When the probe senses smoke, then normally open contact will close, then it will fall to digital input. Okay. Now, if you will, as I said, if you will put it in an analog input, then you should know what you are doing. Okay. Okay. Another one, airflow switch. Okay. This airflow switch, as you can see, there is one probe going to the supply discharge of the fan. Okay, so that in the discharge side of the fan, then I think one of the probe is exposed to atmosphere. So basically this one, if there are two probes, it should be inside the other probe. The negative probe should be inserted at the suction side of the fan. Okay, so anyway, again, this airflow switch, this monitoring points where it should fall. Okay, so if we will follow, it should fall in the digital input. Again, because this differential pressure switch, there will be a normally open and a normally closed contact there. Then you have to set, the technician will set this one to a certain set point. Okay, so if the set point is reached, then that normally open contact will close. Let's say basically this differential pressure switch, the differential pressure range maybe is around 200 pascal. Then there will be a set point there. If let's say you set the set point to around 80 pascal, so when that set point is reached, meaning there is a differential pressure of 80 pascal between this suction and the discharge side, then that set point will be reached. Then the normally open contact will close. Again, it is a digital input because the value is on and off. Okay, so you are correct if you will say it should go to digital input. Okay, then let's say another, this one is a motorized damper. Okay, so motorized damper, it did not show. It did not show. Okay, if it is a motorized damper, let's say your BMS, if you are the BMS engineer, and based on the sequence of operation, BMS will be the one to control this one. Let's say there will be 2 points here, the control and the monitoring. Okay, so if you are going to control this, so there will be two additional points. One is the monitoring. Okay, now actually for motorized damper, if it is an open and closed damper, okay, so what you will give here is an digital output command, an open and close signal coming from the digital output. Okay. Now, if this motorized damper is modulating, okay, meaning or 3-point control, meaning it could open 0%, 10%, 0 to 100%, then the control signal will come from the analog output. Okay, analog output, let's say you have a DDC, is capable of giving an analog control output of 0 to 10 volts or 4 to 20 milliamps. But basically, we are using here a 0 to 10 volts. So, if you will say, okay, kindly there will be 2 additional points for this motorized damper. BMS will be the one to control it and monitor it. So you will add one control output coming from DO if it is an open and closed damper. But if it is a modulating damper, meaning from 0 to 100% opening, then the control signal will be coming from uh, analog output signal. Okay, so one cable or two core cable will go there to give it a control signal of 0 to 10 volts, 0 to 10 volts DC. Now, again, of course, you have to monitor what is the opening of the damper. Again, if it is an open and close, of course, your feedback or your monitoring point will be going to digital, because if you give an open command, it should give you a feedback of open. Okay, that is a digital signal. Okay, so control for open close is digital output, then for monitoring the status is digital input. Okay, now let's say the modulating this damper is modulating. Okay, so meaning it could open from 0 to 100%. So the control signal should come from the analog output, which is 0 to 10 volts. Then what will be the monitoring? What will be your guess? Now, the monitoring should go, because if it is modulating, it is also capable of giving a 0 to 10 volts control output signal that you can use for monitoring the percent opening of this damper, and it will go to analog input. Because you are giving 0 to 10 volt signal, then this damper is capable of giving you also giving back a 0 to 10 volt signal that you can use for monitoring the opening, the actual opening. Okay, so that is another thing to consider here. Okay, now let's look for another. Now here we have here a variable. I think this is a BSD or a BFD, variable frequency drive. Okay, now here we have here a start stop. Okay, we can give a start stop command here. Then speed control, as you can see, speed control is coming from analog output. Okay, because this variable frequency drive is capable of receiving an analog input signal of 0 to 10 volts or 4 to 20 milliamps. Okay, but basically, as per my experience, we are always using 0 to 10 volt signal. Okay, then what else? On off status. Now again here, this on off status is the monitoring point for this digital output. But there is one missing monitoring point here, the feedback signal, because you are giving a speed control of 0 to 10 volts. Now this basically variable frequency drive is capable of giving also a 0 to 10 volts feedback signal. Okay, now what else? So those are the points for a variable frequency drive. Then I have also here a differential pressure sensor. Okay, now actually the differential pressure sensor, from this control signal, the variable frequency drive is the one monitoring the differential pressure output signal. Okay, so meaning this the signal, output signal of this differential pressure sensor, actually it's being given also here. So, but I don't think this is correct. Okay, because you are not giving a differential pressure, you are monitoring it. So it should go to analog input. Maybe it is an analog input signal. Okay, you are not the one giving differential pressure in this differential pressure. I mean, you are not giving differential pressures, any control signal to this differential pressure. Okay, you are receiving what is being sensed by this differential pressure sensor. As you can see, from staircase and lift lobby. Okay, now guys, I have a tutorial for this staircase pressurization. You can watch it in my YouTube channel. Okay, so again, there might be some confusion here. Okay, if you are not sure with this one as a BMS engineer, if you are handling a project, then you can always raise an question to the consultant. Okay. Then this one, I don't think, what is this one? Maybe from fire alarm. Okay. So from fire alarm panel, you will be receiving one digital input. That is fire alarm status. Okay. Then what else? Okay, so we almost cover all these points. So again, as I said, if you are applying for a job as a BMS engineer, one of the tests that might be given to you is to correctly identify the signals. Is it an analog input signal, an analog output signal, a digital input signal, and a digital output signal? Maybe in some drawing, you will see UI, universal input. Now, again, universal input, you can use it for digital and analog input. Okay? Now, guys, as I said, you must be ready in determining what is the type of the signal. Okay, so maybe you will be given a control schematic, then he will remove the point, then you will be the one to complete the point where it will go. Okay, from here, from this drawing, I'm showing you where the point is going. Okay, now maybe one of the question also is, once you correctly identify the points, then tell me what will be the controller that needs to be selected. Okay, so from there, you have to tell, okay, if these are the correct points, you will say, I'll be needing a controller with one digital output. Of course, you can say, I need a controller at least having two digital outputs. Then one, two, three, four, five, a controller having at least five. Of course, you all will always consider spare points. Then analog output signal having two analog output signal. Then analog input, but of course there should be also an analog input. Okay, so what will be your controller selection? At least two digital output, then 1, 2, 3, 4, 5, at least 6 digital inputs, then at least 3 analog output, then at least maybe 2 or 3 or 4 analog inputs, okay, for future use. Okay, so guys, this is the type of test that you might encounter if you are applying for a BMS engineer post or BMS supervisor or foreman or BMS technician. Okay, because for a BMS technician, you will be the one pulling the cable and you will be the one terminating the cable to the DDC. Okay, from field device to the DDC. If you are applying for a BMS foreman, you will be checking the work of the technician. So you will be the one to check the correctness of the cable pulling. If you're the BMS engineer, your job is to do the control logic programming based on this control and monitoring points. Okay, so I hope it is clear with you. First, you can uh, watch this tutorial, okay, in my channel. Then you can check also my other other test that I'm showing you in this tutorial. Okay. Now, maybe in the next video tutorial, I will give you another, but I don't think you will be given a test for programming. Maybe I will show you an example of it. Maybe this one, the next tutorial, you will be asked to, can you write a simple control logic program for this simple control schematic? So that will be another tutorial. Okay, so once again, guys, if you are new to my channel, please help me promote my channel. You can subscribe, click the notification bell, like, share, and put your comment. And once again, before I will end this tutorial, this is Santos Capilan Jr. Always wishing you a good day and God bless us all. Let's all be safe and bye for now.